An easy-to-use transistor model, extensive discussion of useful subcircuits, such as current sources and current mirrors. Single supply op-amp design, easy to understand discussions of topics on which practical design information is often difficult to find. Op-amp frequency compensation, low noise circuits, phase-locked loops, and precision linear design. Simplified design of active filters with tables and graphs, a section on noise, shielding and grounding, a unique graphical method for streamlined, low noise amplifier analysis, a chapter on voltage references and regulators, including a constant current supplies, a discussion of monostable multivibrators and their idiosyncrasies, a collection of digital logic pathology and what to do about it, an extensive discussion of interfacing to logic with emphasis on the new NMOS and PMOS LSI, a detailed discussion of AD, of analog and direct conversion techniques, a section on digital noise generation, a discussion of mini computers and interfacing to data buses with an introduction to assembly language, a chapter on microprocessors with actual design examples and discussion, how to design them into instruments and how to make them do what you want, a chapter on construction techniques, prototyping, printed circuit boards, instrument design, a simplified way to evaluate high-speed switching circuits, a chapter on scientific measurement and data processing, what you can measure and how accurately and what to do with data, bandwidth narrowing, methods to make clear signal averaging, multi-channel scaling, lock-in amplifiers, and pulse height analysis, amusing collections of bad circuits and collections of circuit IDs, useful appendix on how to draw schematic diagrams, IC generic types, LC filter design, resistor values, oscilloscopes, mathematics review, and others, tables of diodes, transistors, FETs, op-amps, comparators, regulators, voltage references, microprocessors, and other devices, generally listing the characteristics of both the most popular and the best types. Throughout, we have adopted the philosophy of naming names, often comparing the characteristics of competing devices for use in any circuit, and the advantages of alternative circuit configurations. Example circuits are drawn with real device types, not black boxes. The overall intent is to bring the reader to the point of understanding clearly the choices one makes in designing a circuit, how to choose circuit configurations, device types, and port values. The use of largely non-mathematical circuit design techniques does not result in circuits that cut corners or compromise performance or reliability. On the contrary, such techniques enhance one's understanding of the real choices and comprise faced in engineering a circuit and represent the best approach to good circuit design. This book can be used for a full-year electronic circuit design course at the college level, with only minimum mathematical prerequisite, namely some acquaintance with trigonometric and exponential functions, and preferably a bit of differential calculus. A short review of complex numbers and derivatives is included as an appendix. If the less essential sections are omitted, it can serve as the text for one semester course, as it does at Harvard. A separately available laboratory manual for the art of electronics contains 23 lab exercises, together with reading and problem assignments keyed to the text to assist the reader in navigation. We have designated with open boxes in the margin those sections within each chapter that we feel can be safely passed over an abbreviated reading.